Welcome everyone. In this video lecture, we will solve a diode based numerical which is from the Microelectronics book by Sedda Smith. So the question is a power diode for which the nominal current at 0.8 volt is 10 ampere. So in the question it is given say is any diode is there which is power diode. Okay. So this one is a power diode. So in this diode the current is 10 ampere and the voltage you can say Vd is 0.8 volt. Furthermore, the designer has reason to believe that eta is 2. In question also given the ideality factor is 2. Okay, we can say the ID current is given 10 ampere and the corresponding Vd is given 0.8 volt. Okay, so these are the given thing. Okay, for the available current source, for the available current source which varies from zero point 0.5 milliampere to 1.5 milliampere. So for example, I am saying there is a available current source, okay, which is varies from 0.5 milliampere to 1.5 milliampere, okay, which varies from 0.5 milliampere to 1.5 milliampere. Okay, so if this is going through that power diode. Okay, so this will maximum 1.5 milliampere 0. So what should be the junction voltage might be expected. So here we can say the ID1 is 0.5 milliampere. So what should be the VD1 we are expecting. Okay, and maximum when ID2 is 1.5 milliampere, what should be the VD2 we are expecting. This one is the question. So again, a power diode is given with the number current of 0.10 ampere at 0.8 volt. Okay. So the designer has ideality factors. We are taking two. So for the available current source, 0.5 milliampere to 1.5 milliampere. Okay, which varies from 0.5 milliampere to 1.5. What should be the junction voltage expected? Say VD1 for ID1 and for ID2, what should be the VD2? And what additional voltage change might be expected by temperature varies from plus minus. That we will do it at the end. So these are the given thing. So from this one we can say Is is unknown. Okay. So as we know the diode equation, ID can be written as Is e to the power Vd by eta Vt. So simply the saturation current of the diode can be written as Id by e to the power Vd by eta Vt. This one is the Is value. So Is value simply we can find by putting ID 10 e to the power Vd is 0.82 into Vt. Vt is 25 milli. Okay, milli means 10 to the power minus 3. So what we have to do? We have to solve this one. So if we solve this one, it will come like 10 e to the power 0.8 into 10 to the power 3 by 50. So if we solve 10, then if we remove this decimal, it will be 500 and 1000. So it should be simply e to the power 80 by 5, or can write e to the power 16. Simple calculation is there. You can easily get 10 by e to the power 16, and if we solve, it will come 1.12 into 10 to the power minus 6 ampere. So we have find the value of 1 point is 10 to the power. So this one is the okay. We have used this formula ID. So is value can be calculated like this. Okay, after putting everything, the is value is this. Okay, so now we have to find VD1 for ID1. This one is now known to us, and another one VD2 for ID2. This. Okay, so what we will do again, we can write ID1 is 0.5 milliampere. So we have to find the value of VD1. So what again we have to start with the diode equation. We can write it ID1 equals to Is e to the power Vd1 by eta Vt. So again from this equation we can easily find the value of Vd1. So I am writing the full expression, or we can write like this. If we take natural logarithm both sides, so taking ln both sides, it should be Vd1 by eta Vt. So we can say Vd1 will be eta Vt times. Okay, so this one is the formula for Vd, or in general we can say Vd equals to eta Vt ln Id by Is. Anything. This one is the formula. We can easily write. Okay. So now we have to find the value of Vd1. So eta value is given to Vt thermal voltage 25 millivolt. Okay. Id1 value is given 0.5 milli, means 10 to the power minus 3 upon Is is already known to us, 1.12 into 10 to the power minus 6. So this can 50 into 10 to the power minus 3 ln 0.5 into 10 to the power 3 by 1.12, or one more line, then 0.5 into 1000. Okay, means this should be our 500 by 1.12, 500, okay, by 1.12. So if we solve directly, if we use the calculator and if we solve, it will nearly 0.305 volt. Okay, so this one is the VD1. Okay, this we have already calculated. Now one more thing we have to find. ID2 is given 1.5 milliampere. Okay, two things we have to find. ID2 1.5 milliampere. So the corresponding VD2 we have to find. So for this purpose again Is will be same. So directly we can write VD2 will be eta times of Vt ID2 by simply Is. So 2 into 25 into 10 to the power minus 3 ln 1.5 into 10 to the power minus 3 divided by 1.12. Is value 1.12 into 10 to the power minus 6. Simple calculation. So 50 into 10 to the power minus 3 ln. Then after, what we can write? One more line, like 10 to the power 3 we go, and 1.12. Okay, or simply one more line. Then I will write the full answer. 1.5 into 1000 means how much? 1500 by 1.12. Okay, 1500 over 1.12, and if we solve in the calculator, it will come 0.36 volt. Okay, so VD2 value 0.36 volt. Okay, so this is the answer for this ID2. Okay, what they have asked. So these two are observed for which varies from 0.5 milliampere to 1.5. So what should be the junction voltages? VD1, VD2. Okay. What should be the junction voltages? We have already find. Then after, what they are asking, what additional, what additional, okay, I'm highlighting this one. What additional voltage change might be expected by temperature variation of plus minus 25 millivolt, 25 degree centigrade. So as we know, for 1 degree centigrade rise in temperature, it causes 2 millivolt per degree centigrade decrease in voltage. Or one can write for 1 degree centigrade change, the voltage change will be 2 millivolt. Okay, so for plus minus 25 degree centigrade, okay, the voltage change will be 2 millivolt by 1 degree centigrade into plus of minus 25 degree centigrade. This degree centigrade, it should be 50 millivolt plus of minus. So for 25 degree centigrade, the possible change in the VD will be plus or minus 50 millivolt. Okay, so this is all about this question. So this was means sentence is little bit tricky, but the question is very simple. You have to first think the basics. Means here it is given 0.8 volt each, means the nominal current in the diode is 10 ampere with voltage VD. So IS we have to find. Then after, the current source is varies from 0.5 milliampere to 1 ampere. So what junction voltage might be expected? So junction voltage might be expected in between VD, in between. Okay, so here once again I want to write, means for this one, okay, we have to select the junction voltage plus or minus the junction voltage, or simply expected in between which range? 0.36, 0.3052, 0.3052, 0.36 volt. So this one is the answer. This is all about this simple question, and this question is from the Microelectronics books. So this is all about this simple question. So thank you for watching this video.